Alright guys, so far there's been a lot of talk about substitution as a way to integrate. Now, it's time to get down to business and it's time to actually start looking at what substitution or evaluating an integral by substitution is all about. Alright, so when we get into a scenario in which we cannot simply just use our power rule for integration or our constant rules and things of the nature that we've been talking about, alright, and we have an issue like we have here, in which there is functions and then things being multiplied and then another function inside of a function. It's starting to remind us of limits and how we started to manipulate the limits to get it into our favor. I don't want to say it's the same process, but maybe your mindset is kind of the same. You have to kind of work some manipulation in there to make sure that you're choosing the right substitution to make things work in your favor. So, let's take a look. The problem says to evaluate sine of x times e to the cosine of x dx. Good news is the differentials and the independent variable match up. However, when we are choosing our u as being part of our u substitution, we have to keep it all in line with one another. Okay. So this is the first time that most of you guys are going to see a u substitution problem, so it might look a little confusing when you start some things off with, but I promise with practice it will get easier. Now, I look at the function e to the cosine of x. That is an integral e to the x with a different value for x, right? The good thing about e to the x is that the derivative is e to the x, and the integral is, or the antiderivative is e to the x as well too. So I kind of want to use that in my favor. And the reason why I want to use that in my favor, for particularly in this case, because look at what's not x. Normally e to the x would be great, but now we're dealing with cosine of x as that exponent. Well, there's definitely a good relationship between cosine of x and sine of x. We know the derivative of cosine of x is negative sine of x, and the antiderivative of sine of x is negative cosine of x. So there's a strong relationship between this exponent in e to the u, alright, and sine of x. So here's how it's going to go. We're going to go ahead and let u equal cosine of x. And now we are going to be changing a couple things on up. Because when I find u to be equaling the cosine of x, I am now going to be replacing cosine of x with u. But remember what we said in the last video. You cannot have a different independent variable from your differential. So, how do we get now, if I'm about to replace cosine of x with u, how do I get my differential in terms of u as well? I'm so glad you asked. Well, think about what it means to be the differential. Taking the derivative. I want du in the place. Let's find a du. Let's take the derivative of u to see what happens here. So the derivative of u, so du, with respect to x in this case, well, the derivative is negative sine of x. Okay, maybe you're starting to see a pattern here. I need du involved. I need to replace dx with du because I'm replacing cosine of x with u. Okay? So where are we going with this and how can we take it into account? Let's take one more step before I rewrite a couple things on out. Well, take a look what's happening in here. There's a du that I can mess with. Let's get du by itself so that I have an interesting setup for a new differential. Alright, why does this help us and why does this work? Now, I'm going to rewrite our original integral, sine x times e to the cosine of x dx. I look at my du. I need to incorporate this into my original integral. negative sign of x. Have to incorporate this into my differential here. Why? Because I need to replace all of that with du so that things are with respects to u. Okay? Well, right now I have a positive sign of x, but I need a negative sign of x. Good news is, we have a great rule of integration that allows me to make this the exact same problem. Negative, negative makes a positive. You starting to see what I mean by kind of with limits, how we had to move some things around and manipulate it to get it into our favor. That's kind of where we're at right now too, manipulating, move some things around to get into our favor. Now let me move it one more time. Now take a look here. E to the cosine of x times negative sine x dx. What do you notice? Negative sine of x dx, negative sine of x dx. That all is du. So this is true that all of this, if cosine of x is u, all of this will equal e to the u times du. I replaced all of this with du since they were equal to one another. Now, look at that fancy integral. Integral of eu du. Man, that is an easy one to solve for. The antiderivative of e to the u, well, we know that as being just e to the u. So, now we have negative e to the u plus c. But remember, u had value. We gave u a new value or a new function, and u was cosine of x. So we wrap this up by replacing u back in there and get our integral. So the answer to our evaluation is negative e cosine of x plus c. Ladies and gentlemen, that is the first u substitution that we have looked on into this school year. Alright, so we have about 3 or 4 more videos of examples that are going to be going over things just like this. Okay? Before we continue on, though, I do want to give you one to give a shot on your own. And let's go ahead and try. Let's try here. Your shot is to evaluate. You want to evaluate the integral secant of 2x times tangent of 2x dx. But I'm going to go ahead and let you know that you should make u equals 2x. So use u equal 2x for this one. Give it a shot and double check that your answer comes out to this. So I'm going to let you know what u is to start it on off with and see if you're on the same page, and then on to the next one.